So we're going to talk about EQs. So here's a little EQ that I've made in Maximus P. If you're curious about how this is made, you can open up the little programming view and see how I did it. But we'll play around. So I've just made an EQ. It's nothing fancy. So I want to talk you through the strategy here is I'm going to teach you EQ today. We're going to look at compression on Friday, and then we'll look at reverb on Monday. And then the following Friday, we're going to do a little recording assignment. I'm still looking for somebody or something to record. So ideally, we need to find somebody who can sing and play an instrument for us in our little booth upstairs.
I can play a piano.
I don't think we can get a piano in our booth, though, is a problem.
Oh, okay.
Anyway, I'll work on that. But if you hear of anybody, a student or something who plays a guitar and sings a song or something to that effect.
There's a lot of high schoolers that do it.
Yeah.
I hear them all the time.
Yeah, we just need, I'm sure there's somebody on campus. We usually are able to find somebody. But we want to be able to record something that has more than one track. So usually the last couple times it's been somebody singing and then playing guitar, and then we can kind of track each of them separately. So we'll do that up in the studio, up in D&P where we have the booth. And then I'm going to give it to you to work with to try to mix it and edit it and EQ it and compress it and reverb it, all that kind of stuff. So ultimately the application of the stuff I'm showing you now will come in a couple weeks when I give you the chance to try to apply all this stuff. Okay, so we're going to move slowly, but ultimately what I would like you to do is, after I show this to you, take it with you and play with it this week when you get to some time to see if you can understand how the EQ really works and try to hear the things that I'm showing you. So there are a few different kinds of EQs. This one is a parametric EQ, which is really the only one you ever really want to use for the most part. Graphic EQs are pretty easy, but they're not very useful actually for a lot of reasons. First of all, they don't give you anywhere near the level of precision that they appear to. So they appear to give you really precise control. Every slider has a little frequency over the top of it. What you don't realize is that frequency that's over the top of that slider in a graphic EQ actually represents the center frequency of a band of frequencies that it's going to manipulate. And depending on the type of EQ, that band could be anywhere from a third of an octave to a half an octave to a full octave wide. And if it's a third octave, so if it's a 31 band graphic EQ, it would be a third octave. And that third octave actually represents the 6 dB down points of the range. So when it drops 6 dB down from the peak, which means there's plenty of frequencies past that third of an octave that it's manipulating as well. So what ends up happening is all of those bands essentially overlap. So if I were to sort of draw it, it ends up looking like this. Okay, each of those peaks being a band.
6 dB down point being where?
6 dB down point being like somewhere around there. But in the end, they overlap. So it's nowhere near the level of precision that you think it is. The other thing with the graphic EQ, and this is in the analog world anyway, is that each one of those filters is a separate circuit. And every electronic circuit generates noise. Okay? And you've just put 31 of them in there. And so whether or not it's being utilized, even if it's just set at unity, it's still generating noise. So graphic EQs tend to be noisier than others. Okay? And then the other kind of really awful thing about them is that you can't change what they do, right? So the bandwidths of those are fixed. So if you need to get at something in between there, you're going to have to create some pattern using multiple filters to try to pull something off, which is really inefficient. And the worst thing you can ever do with a graphic EQ is use it to notch out feedback frequencies. And I see people do this all the time. It's like, oh, it's feeding back. I've got this full graphic EQ here, and I've got a slider for every frequency that could ever possibly feed back. So it feeds back, and I just notch that one out. No. Because think about what's feeding back, okay? A single sine wave is feeding back. And in order to kill it, you've just taken as much as a half octave or more out of your frequency spectrum to kill a single sine wave.
system that you put this EQ?
No. Because the reason it's feeding back is because it's coming out of the loudspeaker and getting into the mic, right? So if you're going to use a graphic EQ to get rid of it, you're going to take a big chunk of frequency spectrum. So you're trying to get a frequency that is, well, actually, I can just demonstrate here. So your graphic EQ, let's get to that third octave EQ here, which is somewhere around here. So let's say you've got something in the range of 500 hertz feeding back. And you say, all right, I'm going to get rid of that. That's what you got rid of. That's a third octave EQ.
Do that? I mean, that's a big cut.
Yeah, but that's what people do.
Gotcha.
Okay. They take that slider and they dump it. Okay? Look at how much frequency they took. I mean, it's starting to affect it down at 200 hertz, 100 hertz, and gets all the way up to almost 1K. That's an awfully big swath to take out of your frequency spectrum in order to get rid of something that is ultimately that big. Okay? So that's one of the worst things. That's what I mean by a graphic EQ gives you the perception that you're being more surgical than you really are. Okay? You're doing this when you think you're doing that. So don't do that.
We can't use it as a dithering component, can we?
As a noise generator? Yeah, maybe. Although it would already have been converted at that point, so no. The dither only works if you apply it before the conversion happens. But yeah, so graphic cues generally are noisy, imprecise, and inefficient.
So why do they exist?
Because they're super easy.
Really?
They're so easy to understand. You don't have to know anything about sound to understand how that works. Right? You can look at it, and within a couple of seconds of fiddling with those sliders, you go, oh, look, the ones over here get rid of the high stuff, and the ones over here get rid of the low stuff. And I could draw a picture of this thing I have in my head of what I think this should sound like, and I'll just draw it with these, and that's what it'll be. It's well, not exactly. But so it's really good to give untrained people who do not have a lot of skill and a lot of training. A graphic EQ can be useful for them because they can wrap their heads around it faster. Okay, but in reality, it's not really all that useful. So I'm not even going to teach you the graphic EQs because I think they're that useless. So what I am going to teach you is parametric EQs. Okay. So a parametric EQ, if I were to actually try to make I showed you I tried to make this into a graphic EQ. A graphic EQ is really a fixed frequency band. So you have a gain control, but the frequency that it affects is fixed and the bandwidth is fixed on a graphic EQ. But with a parametric EQ, you get to adjust all three of those things. So you still have your gain control, which is the boost or the cut, but you also get the ability to adjust which frequency you're going to manipulate. Right? You have full control over that. And you also have control over how big of a bandwidth that filter is going to occupy. So you can be very, very precise and get down to just one or two frequencies. Or you can get really, this is 3 octaves here. That's a 3 octave filter that I've got drawn there right now. So that's called fully parametric. So you have your gain, you have your center frequency, and you have your bandwidth. Sometimes bandwidth is going to be called Q. Q, the letter Q.
You taught that. Can you go, what is the difference again?
So they are inversely proportional to each other. So Q is, there's a mathematical definition of it that I don't entirely understand. I've never needed to, but essentially Q, the way I think of it is Q is a factor of confinement. So you think about the Q of a loudspeaker would be a higher Q loudspeaker is going to be more directional. Okay, and Q in the context of a filter bandwidth is a high Q would be a narrower bandwidth because you're confining the filter more aggressively.
High Q is more directional?
Yes. So in the case of an EQ, a high Q is a narrower filter, whereas a low Q would be a very wide filter. I tend to like, and most people who do sound tend to like, not like Q, that we tend to like bandwidth. So we tend to like knobs that work as bandwidth knobs because bandwidth is labeled in octaves, and octaves are something that's easier for us to understand. So when I like this bandwidth, when it says it's a bandwidth of 1, that's 1 octave. Okay, so it's like an octave band of usable frequency that I'm affecting. So with bandwidth, a higher value of bandwidth is a wider filter, whereas a narrower value of bandwidth would be a narrower filter. So Q and bandwidth are opposite from one another.
Oh, that's totally important.
Yeah. Because when you're stepping in front of this EQ, you got to know, is that a Q knob or is that a bandwidth knob? And if you misunderstand it, you're going to be doing the opposite of what you think you're doing. It's very easy to figure it out. I'll load up some pink noise here and we can show you. All right, so I'm just going to do a really dramatic cut here. So as I move the knob, as it gets bigger, am I taking more frequencies? Yes, so as the knob gets bigger, if you close your eyes, don't even look at the graph. So this is the knob all the way down, and that's the knob all the way up. So is all the way up getting more frequencies or less frequencies? Yeah, you're hearing less frequencies as I take the knob up, which means the filter is getting wider, taking more with it. Right? So this is definitely a bandwidth knob. If it was a Q knob, it'd be doing the opposite. Okay, so you can hear it. You don't even have to look it up. You can just listen to it real quick. Run some pink noise through it. Wiggle that Q, take the gain all the way down. Wiggle the knob, and see what happens. Wiggle the Q knob, and you'll know real quick whether it's Q or bandwidth. But you need to know that before you try to operate that EQ. Otherwise, it's not going to do what you think it's going to do. All right. You can also usually get a couple different filter types. So this is a fully parametric, but you can also get a couple other things. One's called a low pass filter, which would be, let's see here. So here's a low pass filter, and a low pass filter doesn't give you a gain control. So the gain control is essentially disabled at this point. And it's a cutoff. So a low pass is everything below the frequency you select is allowed through, and above the frequency you select, it's going to start being attenuated. Okay. And with a low pass filter, there's different slopes that you can get. The slope here is not able to be manipulated in this EQ, but it's called the filter order. So first order, second order, third order, fourth order. You may have heard of that. The higher the order of the filter, the steeper the roll-off at the cutoff frequency. So a fourth order filter is like 48 dB per octave, I believe.
Higher the work.
No, 24 dB. 40. No, it's 48. So the higher order filter, the steeper the cutoff is. So like a first order filter might only be 6 dB per octave or 12 dB per octave. Yeah, 60.
First order is 6.
Yeah, 6. First
12, third is 18, and fourth is 24.
24. Why did I think 48?
I don't know.
I feel like I've seen a 48. That's pretty aggressive, though. So anyway, there's some filters will let you do that. This is not. So if it's a crossover, if it's a filter designed to be like a loudspeaker crossover or something, it'll give you an ability to manipulate that slope. That's not what I've made here. I've just made an EQ for purposes of like tuning audio. All right. But the bandwidth knob can give you control over the topography of the filter. And the topography of the filter is what happens between the cutoff frequency and the frequencies that are not being affected. So if you look at it, if you can kind of see here, there's this line here represents the actual cutoff frequency, I believe. And you can sort of see that here is where it's theoretically going to begin affecting it. So the topography is all about what happens in between. Okay.
Between the slope and
Between the cutoff frequency, which is what they call a 6 dB down point usually, and the filter being unaffected. There's a couple different topographies out there. Like the real, the one you're going to see the most is called the Butterworth. And the Butterworth filter, it's named after a guy named Butterworth that invented it.
We learned about that in Paul's class.
Yeah. So the Butterworth filter is essentially the Butterworth filter has the sound has dropped 3 dB at the cutoff frequency. Okay. Whereas the other one is called the Linkwitz-Riley. And the Linkwitz-Riley, named after these two guys, a guy named Linkwitz, a guy named Riley. They worked together. They invented this thing. The Linkwitz-Riley is 6 dB, so it's more like this: 6 dB at the cutoff, down at the cutoff frequency. But there's all kinds of other ones. There's the bezel that actually gives you a little bit of a boost right at the cutoff, like that. So at the cutoff frequency, you've actually boosted the sound a little bit before it starts getting rolled off. This is also called filter resonance, which will come in handy when we start talking about synthesizers. So let me see if I can let you hear what filter resonance sounds like. Right, so I've low passed this sucker down at 1K. As I manipulate the resonance, so I'm essentially manipulating what 1K is doing. And you can actually start creating really interesting sounds if you manipulate filter resonance, which is what you do in synthesizers. Okay? So this is just a sneak peek to synthesizers that we're going to do later. Okay. All right, so I'm just that's in a low pass filter. That's what your bandwidth knob actually turns into a resonance knob, and it's really manipulating the topography, or the knee, sometimes it's called, of the filter. Okay, a high pass filter.
That's the knee. I've seen it, like many consoles say knee.
Yeah.
That's the knee.
Well, there's the knee is applied in a couple places. So you can call the knee, that in the context of an EQ, it could be that little that topography, but in the context of a compressor, it's something else. Usually, if you see knee on a mixing console, that it's in reference to the compressor, typically. Okay. So a high pass filter is the opposite.
It's something else. It's different
Yeah.
than compression. Okay.
Yeah. So high pass filter is just the opposite. Again, it's a cutoff frequency, but in this case, everything above the frequency is let through, and everything below is filtered out. So you could also call a high pass filter a low cut filter. Right? No, not a shelf. Low cut. So it's a high pass, aka low cut, or low pass, aka high cut. Okay. Shelves are something different. So let me show you a shelf. Here's a low shelf. With a shelving filter, you actually get the gain knob back. And what you're doing here is, in a low shelf, you're basically boosting everything below the frequency you've selected. So in this case, I have 230 hertz selected, and I can boost or cut everything below 230 hertz. But there's a slope to that, like there is to everything, and so you can manipulate that with the bandwidth a little bit. So how steep is that?
That's what Logic has, right?
Mm-hmm.
That's all the Logic has, right?
I mean, it has a built-in channel EQ that will give you low shelves. Yeah, it'll do this. Okay, so I'll let you hear what this sounds like. I'm just taking a big swath of low frequency. I'm just manipulating the steepness of the shelf. Mathematically, that's what has to happen to get it to go steeper, is it has to start boosting and cutting the extreme edges of it. It has to start stretching them out in order to flatten out the slope. Okay. High shelf is just the opposite. So with a high shelf, you boost or cut everything above the frequency you've selected. All right. So those are your options. You either have what we would, it's called a peak notch here, but that's what you would call a fully parametric band. Would be a band that gives you gain, bandwidth, and center frequency in some sort of a notch filter like this. You could do low pass, high pass, low shelf, high shelf. Those are usually your options. There's another one you might see called a band pass, and a band pass is a low pass filter and a high pass filter bolted together. So in the case of a band pass filter, you set a center frequency and a width, and it will filter everything out above and below that width. So a band pass behaves, at least you control it a lot the same way as you would control a fully parametric, but there's no boost or cut involved. Right? There's the gain knob that gets disabled in a band pass filter, because all you're really setting is bandwidth and center frequency, and then it excludes everything else. All right, let's try to EQ some stuff, shall we? Actually, sorry, one more thing. Let me demonstrate the rule of thumb here with an EQ. Generally speaking, when you're using EQ, you got to start thinking about your natural tendency is going to be to hear the frequencies that you have too much of, or that you have too little of. Sorry. So you're naturally, I've reprogrammed myself, but naturally you're going to say, I need more bass, or I need more of this, of that 4K clarity thing. That's your natural tendency. But what you need to think about instead is, what are the things I have too much of? And here's why. If you're in the mentality of hearing what you're missing, then you're going to start boosting things. Okay? So if I start boosting things like this, what happens? I clip. Clipping's no good, right? We don't like to clip. So if you get into that mentality of, I'm going to boost the things that I don't hear enough of, you're going to create an awfully distorted system most of the time. Most of your sound's going to get distorted. Instead, you need to start listening for what you have too much of. So if I had my way, gain knobs would only attenuate on an EQ and never boost. Because boosting is just such... Because if you're doing all your gain structure correctly, let's say you've got your input gain on your channel and you've got it just right, you've normalized your audio and everything, any frequency you boost on an EQ will clip. If you've done everything else correctly. Any EQ boost you do will cause a clip. So that's no good. You don't want to clip. But you do every time you do a boost on an EQ. So you got to start thinking about it in terms of not what am I missing, but what do I have too much of? And the things you have too much of are the opposite of the things you're missing. Okay? So it'll take you a very long time to train your brain to do this. I've worked at it for years now, and I finally have cracked that one. I even said it backwards to you when I just tried to explain it. Okay? Because I don't even think about it that way anymore. But it's going to take you a while to get there. So start thinking about what you have too much of. The other rule of thumb is never use an EQ to solve a problem with your system. Okay? So if you're using an EQ is not a system problem solver. If you have a frequency response problem with your system, you've poorly designed your system. Okay? So an EQ is not a problem solver. An EQ is a tool that you can use to get something to sound the way you want it to sound. So it should be used as an artistic and creative tool, not as a system problem. solver. So what I mean by that is, let's say that, gosh, I'm not hearing any bass right now, so I'm going to crank the bass like crazy. It's like, well, the reason you have no bass is because you spec'd loudspeakers that don't reproduce bass, right? Or maybe you don't hear the bass because you've got a directional microphone that isn't pointed at the thing you're trying to pick up. That would be the opposite, actually. So if you had a directional microphone and you weren't pointing on an axis, you would hear too much bass and not enough high frequency, because the high frequencies get less directional, or they're more directional. So as you go off axis of those, you hear them less. So you're saying, gosh, where's all the high frequency? I'm gonna get a high shelf here and boost all this. It's like, no, just turn the microphone. Point the microphone to the thing you're trying to pick up, and you'll get all the high frequency back. Okay, that's a system problem. Okay, so don't use EQ to solve system problems. Sometimes you can use it as a stopgap temporarily. So if you're stuck where you are, if it's a live situation, you're stuck at this console, and you got to fix something, you can use an EQ to fix it temporarily. But eventually, next time you get a break, go down there and point the microphone in the right direction. And then you can undo that EQ. Can't tell you how many times I've been called in by people to help them with their equipment. Why does my stuff sound so crappy? Why is it feeding back all the time? All this stuff. The first thing I do is I go in and I bypass all their EQs. And they say, wow, that's such a difference. It's like, yeah, because you've obliterated the frequency response of your sound system trying to solve all these system problems like feedback and microphones not pointing in the right direction and loudspeakers comb filtering like crazy. They're trying to compensate for all those things with EQ because that's what's in front of them. And they just cause more problems. They just end up with bad sound in the end. Yeah, it's not feeding back anymore. And yeah, maybe you don't hear the comb filtering quite so bad. But the frequency response is awful. So anyway, don't use an EQ to solve system problems. And use an EQ to reduce the things you have too much of, not boost the things you have too little of.
Let's say you have a somewhat directional microphone and you want to record an upright bass player, but you want the finger noise. What direction would you point the mic?
Yeah, I mean, you might want two mics in that case. Okay. Because if you put it up on the neck where the fingers are, you're not going to get the resonance of the bass very well.
But I was just thinking of, when you're talking about pointing the mic, if you point it right at the bass, at the bottom end where it produces a sound, it's going to be bottom heavy, wouldn't it be?
Well, not necessarily. I mean, that resonance box is going to resonate everything. Sure, I mean, that's what it's designed to do. So it'll resonate everything. I think what happens, particularly in a recording situation, what happens far too often is that a lot of times, if you got something as big as a bass, right? I mean, it's that whole big membrane that's moving to make all this stuff, and you're going to pick it up at one spot. And really, it's the whole thing that's really making it. And so most string instruments don't really turn into anything until the sound has traveled a few feet, And so it's not that it's going to be bass heavy when you mic it down there. It's just that it's going to pick up whatever is resonating at that one point if you're really, really close to it. But if you move it back a few feet, then all of that resonance will have kind of meshed together, and then it'll get to the mic. And in a live situation, we don't tend to have that big of a problem because we're actually hearing the real thing, right? If it's a concert or a theater show or whatever, you're hearing the real thing, right, without the mic. There's a certain amount of it that you hear, and so the mic is really just, you're using that to pick up whatever isn't quite getting to the audience. But in a recording situation, you'll find this out when we do a recording, that all you get to hear is whatever hit that mic. And so you have to be much more careful about where you place the mic when you're recording because of that. So I think that problem is more about distance than position. All right, so let's give this a shot. All of my examples here are not system problems. This is all design problems. Like I want something to sound differently than it sounds. So I'm going to use an EQ to help me get the sound I want, not solve a problem with my system. Okay? So if I ever see you trying to use an EQ to solve a problem with a system, I'm going to unplug the EQ and take it back. Okay?
You have one message.
Here is, these are all just things from shows.
Bell Atlantic.
Calling with a message for
So this is an
Sam
answering machine message that I made for a show one time.
It is important
This is
that
the same
you
actor
call
doing
our
all these
business
voices. That was part of
offices
the
before
shtick of the
5
show. So
p.m.
one-man show, he
today,
did all the voices,
or call
including
our
the recording.
automated payment line at 869-9000.
So if we listen to this,
That was your last message.
sort of sounds
Hi,
like a
you've
guy
reached
talking into an SM58 in his living room.
522-7003. Please
Which
leave
is
a
exactly
message
what
for
it
Sam.
is. A guy talking into an SM58 in his living
Hello,
room.
you have one
I want to make it sound like a
message.
telephone. Okay? So, what makes things sound like a telephone? Well, it turns out that telephone company runs a band pass filter on everything that runs through the telephone system. And that has to do with transmission loss in the old days of telephone poles and analog signals and everything. They would do high pass and low pass filter on it in order to maximize the distance they could transmit the audio signal without it deteriorating. And so and that has just survived. So that process of band limiting is just still there. So everything that you hear on your telephone there's an EQ essentially being applied to it all the time. And you can look that up if you want. I can tell you right now
Bell
that
Atlantic.
it's somewhere in the range
Calling
of
with a message for
what's left through is somewhere in the range of 500 hertz to 3,000. Okay.
It is important that
So
you
I'm gonna
call our
create
business offices before 5
high-pass
p.m.
filter
today, or call our automated
set
payment
to
line
about
at
500 hertz.
869-9000.
And I'm going to turn on another channel here.
That was your
That
last
is a
message.
low-pass filter.
Hi, you've reached 522-7003.
And I'm going to set that
Please leave a message
to
for
about
Sam.
3 or 4K. 3K maybe.
Hello, you have one message.
This is
Okay, there we go.
Bell Atlantic.
calling with a message for
Sam.
Okay, so there's the 58.
It is important that you call our business offices before 5 p.m. today,
Sounds like a
or
telephone,
call
right?
our automated payment line at 869-9000.
That was your last message. Hi,
Yes? Sorry? What? Yes?
please leave a message for Sam.
I have some settings here. Let's see how close I got to
Hello,
my preset.
you
So here's a
have
pre-programmed
one
one.
message.
There we go.
This is
Bell Atlantic.
calling with
Okay,
a
so
message
a good
for
EQ hopefully is going to give you a bypass button like this, where you can bypass the whole thing on and off, which is very helpful. I do that all the time when I'm EQing something. I do a lot of musicals, and I spend an awful lot of time trying to EQ people's individual mics because it's a resonance issue. You get the mic, gluing it to their face somewhere, and it just. The human voice does the same thing that bass does. It's sort of like there's a whole lot of stuff like rattling around inside your skull that doesn't quite mesh together until you get a few feet away from the person. Okay, I mean we're putting a mic and we're gluing it to their forehead, and it just we're not quite getting everything yet. It hasn't quite evened out, but we're picking it up right there and then putting it out through a sound system. And so I spend an awful lot of time trying to figure out what they really should sound like. I listen to them sing without the mic. I'm like, what does their voice really sound like? And I try to use the EQ to get them to sound like them. And so I do a lot of A/Bing like that. So I think I've got it, and then I'll bypass the EQ, listen to it without it, put it back on, to try to hear what I'm doing. So a good EQ hopefully has a bypass button like that. And hopefully it'll also give you bypass buttons for each band. So this is a 3-band EQ. You could have up to 4 band. I mean, like the Dimitri system has like 10-band parametric EQ. It's just like insane, but you can get it. So there you go. There's my answering machine.
Sam Pelikowski.
It is important that you call our business offices
Let's
before
reset
5
this thing.
p.m. today, or call
All right, let's try another one.
payment
and aerial artistry of the Navy's Blue Angels.
All right, so this is a voiceover actor friend of mine that I use for a lot of stuff.
As they take off
Um,
on their first
and this is from
European tour in 20 years.
Demo reel that he was
Strap
doing.
yourself in for a high-altitude, history-making adventure. You're about to experience the thrill,
So let's listen to it for a second.
and aerial artistry of the Navy's Blue Angels. This video opens the cockpit on this legendary squadron as they take off on their first European tour in
So he's
20
good.
years.
You know, he's got a nice voice.
Strap
Cool voice.
yourself in for a
I'm going to do a couple things.
high-altitude,
So I want to,
history-making adventure.
and I'm going to do the
You're
opposite
about
of what I'm
to
supposed to do
experience
from
the thrill, precision,
just so I
and
can show you
aerial
how to
artistry
fix
of the
your own
Navy's
brain.
Blue Angels. This
I need
video
a little bit more
opens the
bass on
cockpit
his
on
voice.
this legendary squadron
I'd like a
as
little more-
they
little
take
more
off
resonance
on
on
their
there.
first European
Personal
tour
preference.
in 20 years.
So,
Strap yourself in
somewhere
for
in
a
this-
high-altitude, history-making
somewhere in this
adventure.
range.
You're about to experience the thrill, precision, and aerial artistry of the Navy's Blue Angels. This video opens the
Not like that.
cockpit on this legendary squadron as they
He's got
take
such a deep
off
voice,
on
I
their
just wanna
first European
highlight that
tour in 20 years.
Okay, so here it is.
Strap yourself in for a high-altitude, history-making adventure. You're about to experience
And there it
the
is.
thrill,
It's a little bit of a low
precision, and
I just like it. I
aerial
think it
artistry of the
me as the
Navy's
sound
Blue
designer brain in me
Angels.
likes that. Okay.
This video opens the cockpit
I also
on this
want a little bit more
legendary
clarity
squadron as
on
they
his
take off
consonants,
on their
okay?
first European
So that's
tour
going to be in like the
20
4K
years.
range. 3 or 4K
Strap
range.
yourself in for a
So,
high-altitude,
I'll get another one here.
history-making adventure. You're about to experience the thrill, precision, and aerial artistry of the Navy's Blue Angels. This video opens the cockpit on this legendary squadron as they take off
So there it is
on their
without-
first
without
European
the
tour
hyperlink
in
cues.
20 years. Strap yourself in for a high-altitude, history-making adventure. You're about to experience the thrill, precision, and aerial artistry of the...
So I'm just highlighting parts of his voice that I think are interesting and useful, and I like that. Whatever that is, I like that. However, to get that, I had to break my rule, right? And what was my rule?
Never boost the EQ.
Don't boost things. Okay. So how can I accomplish the same thing without boosting anything?
Cut everything around it.
Yeah, exactly.
What
So-
frequency was the bottom boost? Was that 500?
No, like 130.
130?
Pretty low.
So is it okay to listen to boost while listening to try to isolate like what?
If that's how your brain has to work to figure it out, then yeah.
Pull everything else back.
Yeah, I mean, ultimately you'll get to the point where, I mean, that's part of the way you would train yourself is at the moment, it's for whatever reason, it seems natural to want to boost the things that you don't have enough of. And you can start by doing that, but then ultimately you want to figure out okay, how to do the opposite of that. And you'll eventually get to the point where you can just skip right to that part.
Well, because it's easy to identify what it is that you are hearing versus.
It is right now,
there's
but you can
less.
retrain yourself, is what I'm saying. You can train yourself to hear it differently than you're hearing it right now. It is possible. I agree with you that it is natural to think about what you can't hear and want more of. But you can just as easily train yourself to think about it the other way. Right? It's possible.
That would be pretty dangerous. Isn't a low hum at around 120, 130?
Assuming your system hums, yeah.
Mine does.
But, there again, don't use an EQ to solve a system problem. And never let a system problem dictate what you do with an EQ. I could say that the other way around as well. So I would solve your hum. Because if having a hum means you don't ever get to manipulate anything below 200 hertz, then that would be a bummer. Because I like things below 200 hertz. So yeah, let's think about how we might do the opposite of this.
Can't you grab all of it and just bring it all down so the peaks are at zero?
That is one strategy. So some EQs will give you an overall gain for the whole EQ, and you could just like knock down the input level of the EQ, and that's the way to cheat, essentially, is you could take the whole thing input level down, and then the boost is boosting from an already attenuated state. Right? So yes, that is the way to do it. We don't have that ability in this EQ, though. So, because there's just no gain knob for that. So we would basically do the opposite of this filter. So first thing I'm going to do is I'm going to create this dip. Because if you think about it, I've just taken a dip centered at around 500 hertz. It's one of the things I have, a really big dip. Right? So I could do that real quick. Let me take this one. I'll set it to around 500 hertz. And it'll be pretty wide. So let me get rid of these ones. right? Something like that. So if I take that off and put the other ones and just kind of see, so about there and about there.
Maybe a little much.
Yeah, it might be a bit wide, actually. In reality, I've taken it down too much. I really only need about 6. So it's a bit wide. I don't need to be quite that wide. Right, so there's my dip. And so the other way of thinking about what I'm hearing here is I could say
Navy's Blue Angels.
I'm hearing too much of the mid-range.
Opens the cockpit on this
Is
legendary
the other way to think
squadron
about it. Instead of
as
thinking
they
I want more
take
bass
off
and more
on their
high-end,
first European
I need
tour
less
in
mid.
20 years. Strap yourself in for a high-altitude, history-making adventure. You're about to experience the thrill, precision, and aerial artistry of the Navy's Blue
Yeah, if I
Angels.
wanted to be really persnickety,
This
then I
video
could go ahead
opens
and
the cockpit
turn this
on
into a low
legendary
shelf.
squadron as they take off on their first European tour in 20 years. Strap yourself in for a high-altitude, history-making adventure. You're
And then
about
do a
to
high shelf.
experience the thrill, precision, and aerial artistry of the Navy's Blue Angels. This video opens the cockpit on this legendary squadron as they take off on their first European tour in 20 years. Strap yourself in for a high-altitude, history-making adventure. You're about to experience the thrill, precision, and aerial
All right, there you go. I've
artistry of the
accomplished
Navy's Blue
essentially the same thing.
Angels. This video opens the cockpit on this legendary squadron as they take off on their first European tour in 20
I can tweak it a bit more.
Strap yourself in for a high
But in reality, I really could just,
history-making adventure.
I could almost get what I
You're
wanted
about
just
to
using that
experience the
bid.
thrill, precision,
cut.
and aerial artistry of the Navy's Blue Angels.
So
This-
instead of boosting two things, I could just cut the thing in the middle, and I get more or less the same result. Pretty close anyway. Because if you're not hearing enough low and you're not hearing enough high, you could translate it into I've got too much mid.
Isn't that a whole
Right.
like school of thought in recording sound, like EQ reduction or something? Or is
Yeah, exactly. I mean, this is not a new idea. This is not my rule. The don't boost is not my rule. I mean, that's everybody's rule. It's reduce EQ by reduction, not EQ by boosting. Okay.
Video opens
So,
the cockpit
there's my friend
on
Wayne.
this
Sounds pretty good.
legendary squadron as they take off on their first European tour in 20 years.
All right.
Strap yourself in
Here's
for
another one.
high altitude.
A little piece of music I wrote for a thing I was doing. Let's see if I can. Get to my notes here. I have this in here. All right. So if I listen to this, this little bell thing I'm doing up there that is not quite as present as I'd like it to be. And let's see if I can show you where it is. I'll find it for you. That thing. So you hear what that's without it, right? There's my little bells, right? So they're not quite coming through as well as I hoped they would. And then of course I always like more bass. So there's another little thing down here, because I got this great little bass guitar going in here. I'm interested in that as well. So yeah, let's see if we can figure this out. And I got to do it without doing boosts, right? So let me get my high shelf out here. And I really just, some of this, there's some really high stuff with some of the cymbals and stuff is kind of maybe getting in a little bit in the way here. So let me just reduce that a little bit. take out some of this mid a little bit. That guitar is the strums of the guitar is part of what's masking this thing. And then if I really wanted to accentuate that one little bass here, I could do a low shelf here and just really filter out some of this really, really sub stuff that's kind of muddying it up a little bit. There we go. Now I'm getting my bells a little bit better. My bass has got a little bit more thump to it. Yeah. Like automate it?
Yeah.
Yeah.
As you were doing it, that sounded pretty hip. Just the way you were.
Oh yeah, sure. Just goofing around with it. Yeah, you can absolutely do that. So in using an automation curve in Logic, you could automate your EQ. So it's like sweeping and stuff. Yeah, absolutely.
Gotta see how to do that.
Yeah, play with that.
Wait a second. Isn't it a little triangle in the bottom corner?
No, here I'll show you. Let me pull it up here. Let's see, get a new project here. Let's see where let's see when I pull that audio out. Yeah, it's this one. No, don't import tempo information. So let me just loop this a bit so that we can. So let me pop an EQ on here. So maybe my shelf. And maybe I want to automate that. I want to like sweep it. Something like that maybe. So if I turn on automation, hit the A button, and I get automation. And open up another one here. And I can go to my channel EQ. And I want, let's see, what channel is this? 1, 2. Low shelf frequency. And I can start drawing this in. I need to be a little bit tighter, don't I?
But you're just adjusting that one parameter of the shelf. Can you like select different parameters of the low shelf?
Yeah.
And just like the verse?
Sure. Let's do low shelf gain.
Stop it. There's a curve tool. What?
So yeah, sure, why not?
Oh my god. Jason, your Logic
Bad eyesight.
fiend.
Okay.
I know about that curve.
Yeah.
So you picked a low shelf and a low shelf gain.
Yeah, so basically, when you turn on automation, you can pull up anything, right? That's on the channel, right? So if you've got a plugin in, you get all the controllable parameters of that plugin, and you can make an automation curve for that. Yeah, absolutely.
Wait a second. Are those on default?
No. You have to be with a plugin. So if I get rid of the EQ plugin, so no plugin, right?
Duh.
Then my only options are, volume, pan, solo, balance. But you start adding plugins in, and you can.
So any plugin can be automated that way.
Yep.
There's a ton of plugins.
Yep.
Awesome. Ruby. Is that an Omnisphere that we're listening to?
Oh, and the music? I don't know. It's all Logic samples.
Oh, Logic stuff? Okay.
Yeah, I'm not.
It's not on.
No.
I hear that arpeggiator. It sounds like it's arpeggiating frequency rather than pitch.
Right. I don't know. This was 4 or 5 years ago. I did that. I don't even remember how I did it. Okay.
It's good.
I got another one for you. What's that?
Ruby.
Yeah.
We're bringing that word back.
That's right. All right. Here's just a really simple one. Okay. Kick drum. Okay. This is a Logic kick drum. I pulled this out of one of Logic's percussion banks. So what I don't like about this kick drum is it's got too much of that snap. I don't like all the snap. I like a thumpy kick drum, right? And this is a snappy kick drum. So again, I'm not solving a system problem here. It's just how I like it. I mean, this is how it was recorded. I just don't like how it sounds. I like a thumpier kick drum. That's just me. Some people like snappy kick drums. So I'm just going to reduce all the snappy stuff that I don't like. So I'm going to get a high shelf and set it to, what did I decide? Yeah, about 120. Maybe reduce the thing here. Maybe steepen this up a little bit.
Oh, yeah. What was that frequency that the shelving began?
I got it at 120 right now. Right? So that's what I started with. And that's what I ended up with. And of course you got to crank it a little bit now that you've reduced so much. Right? Yeah. There's just a very simple example of how to think about it in terms of not I need more thump, but I need less of that snappy stuff. Okay? Okay, so let me show you now how this manifests in a couple of the different sorts of plugins you'll use. Should have left my little project open, shouldn't I? So that's my little EQ I made, but you obviously, and you can play with that one if you want. You downloaded it from the website if you want. So let me get my music track back in here. Port. Okay, so if you go into your plugins here, Logic has this channel EQ, and that's the one I had first. So this is a 1, 2, 3, 4, 5, 6 band EQ. It also has a high shelf and a low shelf on there that you can turn on if you want. So the filter bypass buttons are on the top here. So you click on these and it engages or disengages the filter. So if I take this one, and the nice thing about this one, you can actually just drag around inside the graph, which is kind of fun. Manipulate it that way. Okay, and I can bypass that with that button, and that's automatable as well. Okay. If you want the high pass and low pass, you just have to turn them on, and then at that point you can.
Oh my god.
Right. But you can automate that too, right? So let's do it.
You gotta automate that in like over a period of like 3 seconds.
So.
Just, like, bring it in and then bring it in.
So let's see. This is my low pass. Where's my low pass? Oh, they're calling it a high cut. Hang on, let me loop here. Loop, loop, loop. Actually, I can loop it like this. Let me just do this and then. Yeah, so I want to do channel EQ, high cut frequency, and we'll start it all the way out. We'll take it slowly down to 300 or so, and maybe slowly bring it back in, something like that. You can see it changing over here.
Oh my god.
Right? So again, we're making art here. We're not solving system problems. These are the kind of things you want to do with an EQ. Stuff like this that's fun and makes it sound cool. Not like stuff that overcomes the hum in your monitors or stuff like that. EQs are horrible at solving those kind of problems, but they're really great at doing this kind of stuff. Okay. So this is pretty flexible EQ. If you look at this, let's see if we can figure out if this is bandwidth or Q. So if I control this thing, look at that, it's Q. When I go to a higher number, it gets narrower. When I go to a lower number, it gets big. That's a bummer. Oh, look, you can swap it though. This Q couple thing. Oh wait, no, never mind. I thought that maybe that would do it. I don't know what that does actually. I have to look that up. Anyway, so that's Q. Let's take a look at some other EQs here. So this is a very similar interface, but it's called a linear phase EQ. Most EQs accomplish their filtering by manipulating the phase. That's how you can get the things to boost and things to cut. A linear phase EQ does it without manipulating the phase, which is this black magic that I don't understand. Why would you want to do this? Well, if you've got some weird interactions going on between this track and another one, when you mix them together, and that the interaction is a result of the phase changes, you can use a linear phase EQ and deal with that. I've never found them to be particularly useful. I know they're very useful for mastering engineers. Because people who do a lot of mastering, they find that those phase shifts that come from traditional EQs can cause them some problems that only they can hear, I'm sure. But presumably we can hear it too. We just don't know it. But that's what it does. It's a very magical device that actually somehow achieves frequency processing without changing the phase, which is like weird to me. Or it doesn't change it, it just keeps the phase linear. So anyway, it's weird to me. Single band EQ, this is just like a one channel EQ, right? Low cut, low shelf, parametric, high cut, high shelf. You don't get a graph or anything, it's very simple. Why would you want to use that over the big one? Any ideas?
Because you want to adjust more than one band.
No, because you're worried about CPU cycles. So if you got a massive session and you're taxing the CPU a lot and you've got that big 10-band EQ on it and you're really only using one band of it, your computer's having to allocate the resources to run all 10 bands when you're only using one. So you could use the one-band EQ and just say, great, I'll make your life a little bit easier to the computer. That's really all it's useful for. So those are the logic EQs. In the waves universe, we have these waves plugins. There are a few different ones. They have this one called the Q Q series EQ, and you can load it up in band numbers. So it's Q1, 2, 3, 4, 5, 3, 4, 6, and 8, and 10, and it's just the number of bands you want to load up. So here's a 10 band Q10 paragraphic equalizer. Paragraphic meaning that it's parametric, but you get the graphical representation of the filter up here on the screen. That's what that means. Yeah, so you get the cool, like, I can see what I'm doing feature, but you also get the precision of the parametric. Again, you're turning things on and off, messing around. Here's your filter types, bandpass. Oh yeah, I can go. Well, okay. So here's the thing. What they're calling bandpass is actually a peak or a notch filter. A true bandpass would not have a gain control like this. You'll see this sometimes. Some people will call this kind of filter a bandpass. That's not what it is, but that's what they're going to call it. Okay. So there you go. Now this one does have an input gain, so this is where you could accomplish your idea of if you do the boosts and then want to get out of clip range, you could reduce the input gain, and then you'd get out of that clip range. That's a good way to start when you're training yourself. Let me show you if we just do some of those filters like I had. All right, so Clip City, right? You can even hear the distortion. So I can go ahead and reduce the gain though, so we can say -6. Get the same effect now, just not clipped. All right, so that's the way around it until you can train yourself to hear it the other way. So that's a good thing about this EQ is it gives you that input gain. They have a lot of cool presets on here. So for example, they've got the telephone one built into it. They have an AM radio.
Is AM radio not different than FM radio?
Yeah.
Well, yes, it does. But like, what is the? Can we click on
AM radio versus full spectrum.
that? Is there an AM radio?
I don't know. No, it doesn't say so. Super notch, what's that? Something stupid. Hum removal, here. Use an EQ to solve a system problem. So
Anti-cone filter.
what it's doing is, so the hum actually has harmonics. So it's picking the 60 hertz fundamental. Oops. Yeah, so it's picking up the 60 hertz fundamental, and then it's doing the harmonic intervals to try to get rid of it. But what did it do to the frequency spectrum to get there? It's not too bad actually. I mean, it's pretty tight, but
Well, it's like the low is.
yeah. I mean, obviously the low is not as exciting, but you got rid of the hum, right?
Did you purchase that?
Yeah. So this is, well, you guys did in your system specs. So that Waves native power pack comes with this Q10 EQ.
For $300, you could get this.
Yeah.
This exact plugin.
This exact. So it comes with this one. It also comes with let's see, the C1 compressor gate, which is this guy. I believe it comes with the L1 limiter, which is very handy, which is this guy. Very useful. So if you want to make your stuff loud without clipping it, it's a limiter.
That's killing.
Yeah.
That's killing.
I mean, I'm squashing the dynamic range, but it's louder now. So if you wanted to make it sound good in the car.
Change the density too. It sounds
Oh yeah,
better.
it's squashing the crap out of it for sure.
What is a limiter? Can you explain a
limiter, well, I'll get more into that on Monday, but a limiter is a compressor that has an infinite ratio. So it just automates the volume so that it never goes past a certain level. In this case, what it's doing is I'm setting a threshold, so I'm saying it might set it to minus 12, and I'm saying minus 12 is the loudest I ever want anything to be, but I ultimately want that to be 0. So anything that's higher than minus 12 coming in, knock it down to minus 12, but then turn the whole thing up by 12 dB. Okay. Anyway, that comes
louder as you turn it
Yeah.
to go down.
Yeah. But you're killing the dynamic range to do it. But it's you know, it can be useful to do what it does.
Well, rockers
Backwards
don't use that.
functionality.
Right, exactly. I mean, they don't want it, so.
Yeah. You want that pump.
I believe that native power pack also comes with these S1 stereo imaging tools, which gives you a mid-side matrix and a cool stereo imaging plugin, which is really fun too. You can manipulate stereo effects with this, so
How often do you use the Waves plugins in your
all the time. So, I mean, you can manipulate stereo imaging
And we have that in Logic.
if you buy the Waves plugins. Yeah, you probably didn't, but but when you spec'd that system for me, one of the things you spec'd was the Waves native power pack. And which is a really cheap way to get in. Waves plugins are really expensive, but the native power pack is pretty reasonable, and it gets you like 5 really useful plugins. It's a great way to get started with really high quality plugins. The other one it comes with is what's called True Verb, which is a pretty cool reverb. It's a reverb that uses thinks about things in terms of the room acoustics. So like how big is the room that you're trying to mimic here? So room size, how far are you away from the source? Are you out in the lobby? Or are you right up next to it?
I gotta have that.
Right? How many dimensions are this room? Is this like 4 walls? Or is this 2 different reflective surfaces, 3 or 4, or what? That just affects the early reflections. Anyway, it gives you control over each of these. It's a good sounding reverb. Okay, so anyway, back to EQs. Let's see. So another sort of EQ that you've got in here is called the Renaissance EQ, which again you get 2 to 6 bands depending on what you want. It's just another parametric EQ. It doesn't give you the input gain though that you get with the Q10, but some people say the Renaissance EQ sounds better than the Q10. I don't know about that, but aside from that, it's just an EQ. It's nothing particularly fancy about it. But some people swear by the sound of it. They say that this Renaissance EQ sounds amazing. I'm not sure what exactly it is they're hearing, but presumably they're hearing something. Okay, so that's just the different ways EQs will show up in Logic, or these same plugins will show up in Triumph or whatever. Apple ships their own, so if you go to Apple's audio units here, they've got a graphic EQ, which is really hokey. Don't ever use that. They give you what they call an N band. I don't know what that means, but it's just that you can decide how many bands you want to have in it, I guess. But it gives you full parametric control. These are free. These come with your Mac.
Have you ever used any of those Mac things?
I don't use them very often. I mean, why would I when I've got like the $3,000 Waves Diamond Bundle plugins? Like, why would I use it? Even if I don't even care if the free one sounds good. It's like, why would I ever use it? I spent $3,000 on the stinking Waves plugins. I'm going to use those every chance I get. Are you kidding me? I'm going to get our money's worth out of that. All right, so no homework per se, other than go and play around with EQs. Okay.
I'll show you.
Vocoder. Yeah, we're out of time, but we can look at that on Monday probably. No, next Friday when we do the special effects.
Okay.
We can look at that.
I do have a question.
Okay.
But it's less specific. Just what makes, like, because everybody always says, like, this is a good EQ and this is not good EQ. Like, what makes an EQ worth spending $3,000?
I mean, we didn't spend $3,000 on an EQ. We spent $3,000 on a plug-in bundle that gave us lots of things, including EQs.
But, like, some people do.
Some people do.
I would like why.
I don't know. There's with the EQs, the math for an EQ is really straightforward. There's really, I believe, when you get into things like reverb and special effects and things, I can see definitely hear the difference between the different from plugin to plugin. But when you're talking about EQ is EQ for the most part. The only real difference is whether you're dealing with the linear phase or not. And even I have a hard time hearing the difference between those. So I don't know. It boils down to the interface, I think.
Okay.
Does the interface make sense to you? For example, Waves also ships out these what they call one knob plugins. And these are meant to be like really, really simple interfaces. So here's a one knob filter. And it's like, you don't need to even know what it does. Just turn the knob, right? What is it? What's it doing? Listen to it.
It's taking out all of the highs.
It's a low pass filter.
Yeah, okay, right. Just turn the knob.
Right? They got a whole bunch of these. They got one knob driver. Let's see if I can find that one. Yeah, one knob driver. This is like distortion, overdrive. Some people really like that interface, right? And they'll pay money for that. When in reality, all they're really getting is a gain knob and a low pass filter.
Okay. Well, I say that to say.
Is that worth $3,000? I don't know, but I'll tell you what is.
The waves.
I'll tell you what is worth $3,000. This is worth $3,000 alone. That plugin. I use this on everything. We'll get into this on Friday, but the L3LL multi maximizer.
What is that under?
That's a Waves plugin.
I know, but what under?
You don't get it with the native Power Pack bundle, unfortunately. It is a multi-band limiter, which means it does all the things that L1 does, but it does it at a frequency-conscious basis. So it only starts limiting the frequencies that are getting out of hand. It's a mastering processor, basically. Okay. So it's amazing.
What is the difference between if you use the limiter versus you just turn the volume knob on your track? I don't know. I guess I'm just trying to figure out what.
Well, because this one is compressing the dynamic range, and the volume knob is just turning it down or turning it up. We'll get into dynamic range more on Friday. We don't have time, but this is if you're talking about what's possibly worth $3,000 to spend on that one.
Well, it's not a
Why
Jason
do you have
Lonnie
those? I don't have
What do you want?
Oh, those are just automation. I did a recording, a complicated recording a couple months ago, and I had to turn on a few of these extra things at some point. And it's about monitoring. So, because I had fold-back monitoring into the headphones of the singers, and they were singing their tracks and stuff, and I had to be able to, during the recording, manipulate the way their monitoring was being dealt with. So which tracks they were. So it's whether you're doing automatically or whether I want to hear it at all. It's just there's a global setting for that in your preferences.
Okay.
So it's just controlling whether you're doing the software monitoring
Sorry, my line gets blown.
and whether the inputs themselves get monitored automatically or if I have to do that manually with this button.
I don't really need that.
Yeah. So I just had to turn those on for some reason for that recording because I was getting sick of digging into the menu to get at them. So I just popped that in as a button.